Hey everyone, and welcome back. All right, so today we are going to be looking at continuing Unit 4, which is Polynomials and Factoring, and we're going to be multiplying monomials and binomials today. So monomials, single-term expressions, binomials, two-term expressions. So we're going to look at doing monomial times monomial, monomial times binomial, and then binomial times binomial, and how we do those. And that will eventually build us up to tomorrow or the next day where we're going to do polynomials. So we're going to go bigger than two terms. Essential questions for today: what happens when you multiply terms together that have a matching variable? And then how do you multiply two binomials together and combine their variables? Let's get started. So when we are multiplying expressions that have the same base value, so this can be number or variable, so for example, if I was doing 2 to the power of 3 times 2 to the power of 5, this one has the same base value of 2, same base value of x, whatever it is, they are going to follow the same rule, and that is when the base is the same, you can add the exponents together. So the reason being, if we look at this one with a, we've got a squared, which is a times a, so that's what a squared is, and then we're multiplying it by a cubed, a times a, which when we simplify that together, that is 5 a's being multiplied, so that is a to the power of 5. So that's where this adding thing is coming from. If the variables do not match, the base values do not match, then they simply just slide in next to one another, and that implies that they are multiplied. So nothing else you need to do. Same thing with the last one, x squared y times ab would just be ab x squared y. Okay, so when we do multiply two monomials together, you're going to look at the coefficients first. So coefficients will multiply, so 3 times 6, 18. Then you look at the variables. If they do match, then we look at increasing the exponent. If they don't match, they just stay as they are. So like in this one, we've got 4a squared times 3ab, 4 times 3, 12. A squared times a, remember if there's no exponent, we assume it's to the power of 1. A squared times a will be 3a, so we got an a cubed, and then there's a b still left over at the end. And then 6g times 4, even though 4 has no variable, it's just 6g's times 4, which would be 24g's. All right, take a shot at these. So these are all monomials, single-term expressions. You can ignore the parentheses. Something to note, I put stars or asterisks in between these to signify multiplication. This could easily be rewritten as 3a squared minus 2a, so they're just parenthesis beside parenthesis, or it could be 4x with a dot and then xy. Those all mean multiplication. So beside each other, dot, stars, they all signify multiplication. I try to avoid x's, mostly because I don't want us getting confused with the sheen. So that's what this italic x is, sheen and a multiplying x. So we'll always refer to it as 4x. I'll never call it 4 sheen, but that kind of italics x versus the multiplying x, we don't want to confuse those. So use dot, stars, or pushing parentheses beside each other. Pause the video, come back when you're ready to see the answer. All right, so 3a squared times minus 2a, 3 times minus 2 is negative 6, a squared times a, there's now 3a, so that's a cubed. 4x times xy, 4x, and there's two x's in it, so it's going to be 4 times 1, because xy has no coefficient, so we just assume it's 1. X times x is x squared, and then there's a y there too. Minus 5gh times minus 4 fg squared h cubed. So minus 5 times minus 4 is positive 20. We've got fgh. F doesn't have anything to combine with, so it's going to be just f. G, there's g to the power of 1 on the left, and g to the power of 2 on the right, so that's 3g's. And then we've got h to the power of 1, h to the power of 3, so that is h to the power of 4. So we get 20f cubed h to the power of 4. Last one, 7x cubed y squared z to the power of 4 times 3x to the power of 5 y z squared. 7 times 3, 21. X cubed and x to the power of 5 would be x to the power of 8 when you combine them. y squared and y would be y cubed, and z to the power 4 and z squared would be z6. All right, so when we've got binomials, so we've got two terms multiplied by two terms, this one is where we use the distributive property. And you should be familiar with this from middle school, but if you're not, no worries, I'm going to go through it with you. What it means is everything in the first parenthesis, so the first parenthesis is x minus 5, times everything in the second parenthesis. So everything has to get multiplied at some point. So x has to get multiplied by, so the x in the first one has to get multiplied by the x in the second one and the 2. The minus 5 in the first one has to get multiplied by the x and the 2. The only thing that does not multiply is like x does not multiply by minus 5 and x does not multiply by 2. So it's everything in one parenthesis times everything in the other. So the way I like to do this is I track it with these little arcs. So x times x is x squared. X times 2 is 2x, minus 5 times x is minus 5x, and minus 5 times 2 is minus 10. So I then notice that I've got two terms that contain x's, so I can combine those, just like we did in our last class. 2 minus 5 is minus 3x, and then we've got minus 10, so that would be my final simplified answer. So everything in the first times everything in the second. Let's take a look at another. So this one, different letters, kind of more like what we were just doing with the monomials. We've got everything in the first, so a, we'll start with this a. A times 2a is 2a squared. A times minus 4bc is minus 4, and then I've got abc. 3b times 2a is 6ab. You can write ba or ab. It doesn't matter when you multiply. The order of multiplication is not important as long as they are all included. I like to go alphabetical order where possible though. And then 3b times minus 4bc is minus 12. And then we've got b times b, which is b squared, and we've got a c as well. And at this point, we're done. If we want to write it in grammatically correct order, we would go in degree order. So a squared, this is a degree of 2. ABC is a degree of 3. AB is a degree of 2. And b squared c is a degree of 3. So I should have 2a squared minus 12b squared c minus 4abc plus 6ab. So just the higher degree numbers at the front, the lower degree ones at the back. That's it. All right, so it's your turn. We're going to take a shot at these four. Pause the video, come back when you're ready to see the answer. Okay, so first one, we've got 3x times 2x, so it's 6x squared. 3x times minus y, minus 3xy. 4 times 2x is plus 8x, and 4 times minus y minus 4y. There's no like terms in here. We have some x's, but they either have a y or they're in a different degree, so we are done at this point. Next one, 3x squared times 4x is 12x cubed. 3x squared times minus 7 minus 21x squared. Minus 2x times 4 is minus 8x squared. I'm sorry, there's x's in both. And minus 2x times minus 7 is plus 14x. So then one thing we do note is there are two values that contain x squareds. So this can be simplified a little bit further. So we get 12x cubed. Minus 21 minus 8 is minus 29x squared, and then 14x. Now we're done. Third one, a times 4a, 4a squared. A times minus 6b, minus 6ab. 3b times 4a plus 12ab. And then 3b times minus 6b minus 18b squared. Got matching terms in the middle there. So I've got 4a squared plus 6ab minus 18b squared. Done. And the last one, x times x, x squared, x times minus 7 minus 7x, 7 times x plus 7x, and 7 times minus 7, negative 49. So these actually cancel. 7x minus 7x is 0x, and we get x squared minus 49 is my final answer. That brings us to the end of today. You have Khan Academies assigned to you that are going to go through multiplying monomials and then multiplying binomials and monomials together, or monomials and a couple of polynomials too. But write them down, use your distributive property, use highlighters if you need to mark like terms, and until you get very confident at it, try and make sure you are using paper as much as possible. Essential questions: what happens when you multiply terms together that have a matching variable? If the base value matches, so the variable matches, you are going to add the exponents together. If you multiply two binomials together, you're going to use the distributive property. So everything in the first times everything in the second, and then we combine like terms. So we multiply like we do with monomials, and then we combine like terms at the end like we did with adding and subtracting. And then for tonight, you have your Khan Academy to do. All right, thanks for being here. I'll see you next time.